So, just like yesterday, I want to check your energy. So, when I say Python, you say Asia. Python? Once again, with more energy. Python? Okay, very good. So, right now, I want you to. Okay, very good, Kyle. So, I want you to please scan the QR code on the left or go to slido.com and type in the numbers. Okay, so I am a teacher, by the way. So this is a quiz. I want to learn how much you know about Python today. Okay, so let's just wait for a few seconds for you to join in. Can you guys see me? I'm too short, sorry. Okay, I think. Are you guys okay now? Okay. Let's just wait for others to join in. It's very easy. You have only two choices. It's myth or fact. Okay. Let's start now. So the first question is, you need advanced math skills to learn how to code. Is it a myth or a fact? You have 15 seconds to answer. Open, no? Okay, very good, children. Wow! Okay, second question is, Python is named after a snake. Is it a myth or a fact? Let's see your answers. Oh no! The real answer is that it is a myth. So if you don't know, Python is named after Monty's Python Circus. So it is a comedian show that was being watched by the creator of Python, which is Guido van Rossum. So if someone asks you if Python is named after a snake, what's your answer? Is it yes or no? Okay, very good, children. Please remember that, huh? Okay, the third one. The very first computer programmer in history was a woman. And with this, I would like to everyone to be there at the Pi Ladies launch later on. Oh, the answer is fact. So the very first computer programmer is none other than Ada Lovelace. So if someone asks you if the first computer programmer was a woman, you should answer yes or no? Yes. Okay, very good. And that is why also they say that programming is hard because it's made by a woman. It's very controversial. Okay, number 4, block-based platforms like Scratch are not real coding. Is it a myth or a fact? Okay, the answer is myth. Block-based platforms like Scratch, mblock, and Code.org are real coding. They are used by students, especially those little ones, primary or elementary students, as an introductory phase before they learn text-based programming like Python, Java, C, and more, and so on and so forth. Question number 5, learning to code can actually improve a student's skills in reading and writing. Is it a myth or a fact? Okay, the answer is fact. Let's move on to another question. Good programmers memorize all the syntax and commands. Is it a myth or a fact? 2 and 1. The answer is it's a myth. For those who answered fact, if I ask you if you remember all the syntax and commands, can you answer it to me right now? Okay, I will not reveal those people, but it's great if you remember everything. I envy you. Question number 7, third to the last. Students need high-end, expensive computers to learn Python. Is it a myth or a fact? Okay, the answer is myth. You don't need high-end, expensive computers to learn Python. The 8th question, Python is currently the #1 most popular programming language in the world. Is it a myth or a fact? Let's see your answers, PythonAsia. Okay, the answer is fact. So, just like a fun fact, on one of my research here in De La Salle University, there's like a benchmark for programming languages. And actually, Python is, for over many years, it's been one of the most popular programming language, top 1 among other programming languages in the world. Python is the primary language used to build AI today. Is it a myth or a fact? Okay, the answer is fact. And lastly, getting error messages means that a student is failing at programming. Is it a myth or a fact? This is the last question, by the way. Okay, the answer is a myth. But if you are my student and you keep on having errors, your grade will be? No, that's just a joke. Okay, so let's proceed with my presentation. So give me a quick second to... Sorry. Okay. Okay, so hello everyone. Are you still alive? How's the quiz? Is it good? Okay, thank you. So, thank you for participating once again. Python? Okay, it's good to hear that you're still alive. So, welcome everyone. And thank you for joining me here today. This is actually my first time attending PyCon, and I'm very grateful to be back on stage again because yesterday I was here in one of the lightning talks, and if you were there, some of the ideas might feel familiar to you. So today I'd like to build on them and look at the bigger picture. So before we dive in, let me take a moment to introduce myself. So hello, I am Rodilyn Joy A. Leonorio, also known as Teacher Joy, or if you are my friend, you just can call me as Joy. I work with grade school and high school students at Makati Hope Christian School, Ortigas. I teach them Python and I guide them as they begin their coding journey. I am also a graduate student here in De La Salle University, Manila. To be honest, I wasn't originally planning to be a speaker or even as a poster presenter here in PyCon. I actually applied to be a volunteer, but sadly, I did not get in. one of my friends from the organizing team, I don't know if he's here, but shout out to you, Lay. He encouraged me to just take a chance and submit my proposal anyway. And at that time, I did not expect much because my topic is not hands-on. And I still consider myself as a beginner. I've only been learning Python for 3 years. But I'm truly grateful for PythonAsia for giving me the opportunity to be here today. And I think that is exactly why this topic matters to me. Today, we are going to talk about how I teach coding to young learners through Python and why our goal as teachers is not to build coders, but to develop thinkers. So I want to start by asking a question. How old were you when you wrote your first line of Python? Can I see a show of hands? How old were you? Yes, Sorav? 16. Wow, you're so young. What about the others? 24, yes? 23. Who else? Yes. 25? 24. Okay, so I think Sorav is the one with he learned Python when he was 16. So that's like very early for his age, no? So let me be honest with you. I wasn't able to learn Python at school until I was an intern. So in the grand scheme of things, I still consider myself as a beginner. Today, I teach ICT to middle school and high school students from grade 6 to grade 10. We cover a massive spectrum. I also teach HTML and CSS for web development. I also teach C and Java and also Python for programming and physical robotics using MakerZoid and Arduino. But watching my students react to Python compared to other tools completely changed my teaching philosophy. If you have ever taught C or Java to a 12-year-old, you know exactly what the syntax struggle is. You spend a whole class explaining public static void main, curly braces, and semicolons. And if a student misses one semicolon, their program breaks. They get a massive error wall. And they feel like they already failed my subject. The heavy syntax drills leave beginners frustrated. They spend 90% of their brain power fighting the language, and only 10% actually solving the problem. The joy of creation gets buried under grammar rules. Across the past decade, education research has aggressively shifted. We realize that teaching kids to act like human compilers is not helpful. The tech industry moves too fast. The languages that we teach today might be obsolete by the time that these kids graduate. Research shows that students learn much better when lessons center on thinking skills. We need a language that gets out of their way. This is where computational thinking comes in. This is the global trend that we are aiming for. So if you can see, we have their decomposing or decomposition, which is breaking a big problem down into smaller chunks. We also have pattern recognition, which is about finding similarities. Abstraction is ignoring the useless details, and algorithms are creating step-by-step solutions. So when a student builds a project, we want their cognitive load focused right here on this diagram, not on memorizing where a bracket goes, where a semicolon goes. And why Python fits that puzzle. Python is the Goldilocks language. It is not too childish, and it's not overly rigid. It reads beautifully, almost like plain English. Because the design is so clean, a student can literally say, if the temperature is greater than 30, print hot. And the code looks almost exactly like that sentence. It allows them to focus purely on the logic. Let's talk about practical application in the classroom. Many of my 6th graders come in having used code.org and mblock. They understand loops and if statements visually. Transitioning them to text-based code like Java is terrifying for them. It's a massive leap. Python is the perfect bridge. The transition is smooth because the structural logic they learned in blocks translate directly to Python's simple syntax without the clutter. One of the most exciting parts of our curriculum is robotics. We use tools like MakerZoid and Arduino. When students write Python code to make interlocking building pieces move, or a sensor flash, the logic leaves the screen and enters the physical world. If the build turns left instead of right, they immediately see that their algorithmic thinking needs adjustment. They debug the logic, not just the syntax. It becomes a powerful confidence booster. Beyond robotics, Python is incredible for showing students that code is a tool for understanding the world. We do simple data tasks. And what are those? So we are writing a program to calculate their average, the average of their test scores, or even sort a list of their favorite movies or favorite places to go to. And with that, they start to realize that the apps that they use every day are just managing data in the background, and now they possess the tools to do the same. When my students leave my class, I don't care if they remember all that I've taught them. I care that they know how to approach a problem that they have never seen before. By teaching Python, we build confident problem solvers. If their future job requires them to learn a completely new digital tool or AI platform, they won't panic. They have the foundational algorithmic thinking required to adapt. Before we wrap up, I want to issue a direct call to action to the curriculum developers and decision makers in the Philippine education system. We are currently seeing a massive overhaul in our senior high school curriculum. DepEd is trimming the 15 core subjects down to just 5 or 6. Because of this, crucial subjects like media and information literacy are being removed from the core lineup. If our students are losing that dedicated digital literacy training in senior high, we absolutely must update and strengthen our ICT curriculum in junior high school. We need to give more attention to computational thinking and not just general critical thinking. Critical thinking teaches a student to ask, is this information true? Computational thinking teaches them to ask, how did the algorithm decide to show me this information? So please, to our curriculum developers, give us an updated junior high school curriculum that prioritizes this algorithmic logic so our learners are not left defenseless in a tech-driven world. And to my fellow teachers, my call to action for you is to step into the gaps. When curriculums change and subjects get removed, the responsibility often falls on us to make sure that the students still get what they need. You do not need to be a software engineer to teach Python or algorithmic logic. Remember, I didn't even learn this language until I was an intern. Shift your mindset from being the syntax police into being a thinking coach. When a student gets an error, ask them, what were you trying to tell the computer to do? Learn alongside them. If we model adaptability and show them how to navigate this changing digital landscape, our students will do the exact same. Finally, I have a call to action for the parents in the room. I know the phrase screen time brings lots of anxiety, but we need to separate passive consumption, like mindlessly scrolling through TikTok, from active creation. When your child is writing Python code or programming a Makerzoid robot, they are building. They are using their screen as a canvas, not just a TV. Please, you do not need to know a single line of code to support them. When they get frustrated because their program is not working, encourage them to embrace the debugging phase. Do not rush to fix it for them. And do not let them quit at the first error message. Ask them, walk me through your logic. How are you going to figure this out? If we praise their discarte and problem-solving process at home, rather than just waiting for a perfect report card, we raise resilient kids who are not afraid of a challenge. To wrap it up, stop dealing syntax and start building thinkers. Use Python because it respects the learner's time and brain power. And remember that our ultimate goal is digital citizenship and adaptability, preparing them for a tech-driven future that we cannot fully predict. As we wrap up our session, I am going to leave this slide up. Teaching can sometimes feel like you are on an island, especially when you are trying to push for new methods or change a curriculum. But it doesn't have to be that way. On the screen, you will see QR codes from my LinkedIn and Instagram, so please pull out your phones, scan them, and reach out. Whether you want to collaborate on shaping a logic-first curriculum for your own school, share your classroom wins, or just talk about the everyday realities of teaching middle schoolers, I would absolutely love to connect with you. Thank you so much for your time. Thank you, PythonAsia, and let's continue shaping the next generation of Python learners.
Thank you so much, Rodeline, for that very eye-opening talk. We have more time. Do you have any more questions? If you have questions, you may go here.
Hello. Hi. Okay, so the reason why I'm so interested in this talk is because we have the same advocacy. So I'm Johannes Pasqua. I'm a professor at university, and it's my passion also to teach kids. No? So I've developed systems before, and I think we have the same struggles. So I would like to ask these questions. I think the first you have mentioned about Arduino, right, and MicroPython, and you're going to teach kids the hardware stuff. Because the good things about kids is that they want instant gratification. As you said, if you teach them Java directly, the syntax will kill them. And syntax error is part of life for programmers. What's important is what's the output, right? Okay, and syntax error will kill the creativity. So that's why Scratch and all these block-based programs are so good. But the problem I see with the block-based program is that it's more of the procedural, right? Because it's sequential, right? For loops, half loops. But it lacks the concept of object-oriented programming. So that's the limitation, I think, of block-based system. And when we talk of Python, you cannot really grasp Python if you don't have that idea of what object-oriented programming is, classes and objects. Because Python is centered on OOP. And that's the challenge for us, especially if you teach it to younger generations. The question is, how do you teach object-oriented programming to kids?
Okay. So, sorry, what's your name again? I wasn't able to
Johannes Pasqua. Johannes Pasqua.
Johannes
Yeah.
Pasqua. Thank you po for your question, Professor Johannes Pasqua. So, in our school at Makati Hope Christian School, Ortigas, we only teach the introductory phase to the students. But when I was an intern at the main campus, the ICT teacher in that campus teaches object-oriented programming to the kids. But I wasn't able to be there for like a longer time because my internship was like 3 months. But I'm trying my best because our school is new. So I'm teaching for 2 years, and the school also is running for 2 years. So the kids that are enrolling in our school, they don't have any backgrounds in programming in their old school. So as much as I want to have object-oriented programming in my curriculum, I cannot teach and have it because they don't know the basics. So I'm starting, so it's really hard for me to teach OOP if they don't know the basics. So right now, I'm only focusing on the introductory phase, like the basics of Python. I'm so sorry po.
Just one more. Okay, so that's why it's quite hard. So we agree that OP is really not that easy to teach to kids. But I think it can be done, right? Now, another question that I'm quite is between the hardware stuff, right? So Arduino is very popular. I think everyone. But the problem I think with Arduino is that it's easy to start with, but it gives students what we call copy-paste programmers. Yes. So they use Arduino because of the billions of documentation. And the problem is they could get started right away. But the problem with that is that they just rely on pre-built libraries. And they don't know how the libraries work. So when things go wrong in their projects, they don't know what to do because they are copy-paste programmers. And that's what I see with the Arduino platform. No? So that's why I welcome you. You have mentioned MicroPython. I'm an advocate of MicroPython also. And also, it pains me, actually. It pains me because the choice between Arduino and MicroPython seems to be quite missing out, right? Why is Arduino so popular wherein there is already MicroPython? Wherein you can use Python to program hardware stuff. But it seems to see everyone is still shifting to the Arduino platform, right? And actually, it doesn't teach coding. It actually teaches them to have copy-paste programmers, actually. So that's why the good thing about Python is it really teaches us coding skills. So what's your take on this? Kumbaga, how have you experienced why Arduino is the in thing, and why do you think that Python in the hardware stuff is not gaining ground?
Um, Actually, I am very strict in in that thing with the copy pasting or using AI to,
Yeah.
because I cannot control all the kids. They can search even if I'm monitoring their computers. They can search on their phone what their code is, and they just can copy paste it into the computer. So with that, um, what I'm trying to do, my strategy in my classroom. So we actually collect the phones, the gadgets, before we start the class. So they will not be able to use it for like the whole period. They are allowed to get it emergency and on dismissal time only. And then when I'm teaching Arduino, I am not um, I am not like, oh, this is my code. You just have to copy and paste it. So what I do is like a problem solving, like fill in the blanks. Like, what do you think will happen if I change this to something like this? So that is how I teach Arduino to prevent the copy pasting and the usage of AI. And in terms of any other platforms, I like MicroPython. In our school, we only have Arduino as the provider that we have for Arduino. They only offer that and not other things po.
Okay.
Thank you.
Rodlin, thank you so much for this wonderful talk. And I think the question which I had, you might have already answered. but let me ask it regardless. So, what are your thoughts on kids using AI for the learning process? The good and bad aspects of it. Thank you.
Okay, so that's actually a nice question. I wasn't able to catch your name, but thank you so much. So for me, at the very first, in this year, school year 2025-2026, for like one whole quarter, I taught my students AI, how to use it, how to prompt properly, and then in our school, we do not have policies for AI. So it's very sad that we don't have it. But in my subject, in my curriculum, I am putting there, whenever we have a performance task or a written work, AI usage policy, banned or allowed in certain contexts, and the other level is they are permitted to use it. So I teach them that so they know how to use it properly. But I am establishing boundaries, like I literally paste it on the screen, like it's not allowed to use it during this time, during this task, so they won't. Or else their score will be deducted. So that is how I do it. But that kind of policy is what I learned from De La Salle University. So De La Salle University, they have this AI usage policy for every task that we have. So even if I'm in graduate school, they also practice it. But I think they are more stricter in terms of the bachelor's degree rather than in master's. But our professor even encourages us to use and leverage AI in our coding works as long as in the scoring rubric, more points are given if you can explain your code properly. Because if you can, they will know that it's from AI. And I'm also doing that to my students. So AI usage policy pasted on my presentation, and also for the rubrics, I'm giving them more points if they can explain it well. So yeah, that's all. Thank you.